Assalamu alaikum. Hello everyone. This is the first episode I decided to record in English, and actually this is in purpose. The idea is I would like to share my experience with GraalVM, and I decided to use GraalVM recently to test it with cloud native application and the microservices. And in this episode, I would like also to share with you the drawbacks I found from my point of view, and also benefits and playing with it. So from the official website, they mention build faster, smaller, cleaner applications. If you go to the overview of GraalVM, you will find they mention clearly that GraalVM provide you a native image, so it is working as a GVM compiler, a tiny native image in size, and very tiny actually. And they also mentioned that it provides you with 100x faster and peak performance with no ramp up. Also, it does not utilize much CPU or memory. It comes with cost. So they mentioned GraalVM reduce the attack surfaces. It excludes unused classes, methods, and fields from your application. It also restricts the reflection and dynamic proxies. And this is happening actually by scanning or doing static analysis for your code. And to do static analysis, they are doing this ahead of time. And because of this, you will get some slow time in order to build your application. This might be a drawback of using GraalVM in comparison with normal applications from Java. However, you will get extremely fast startup time. Right now, there is lots of frameworks already provide or support GraalVM, Spring Boot, Micronaut, Quarks, and also cloud platforms like OCI and AWS. This is from the official website, but now let's try it with one of the framework they mentioned. I have experience with Spring Boot, so let's start with Spring Boot. And from Spring Boot official website, they mention that they provide GraalVM native image support, and they also mention the same limitation in GraalVM. However, Spring Boot overcome this by doing everything ahead of time. Also stop the lazy loading. There is no lazy loading with GraalVM when using Spring Boot. So the idea actually is Spring Boot was loading the beans at runtime, but now the beans definition itself will be populated ahead of time. With GraalVM, everything will be loaded at the beginning. To test this, actually, they provide a Docker native image support, and this is done by buildbacks. And buildbacks, actually, there is two builder I found. The builder mentioned from Spring, and I also found Dashon provide a tiny builder, and this is specifically for Mac Silicon chip. And fortunately, I am using Mac Silicon chip, but I would like first to try the official one. If we gonna use Maven, is only having Spring Boot starter and this plugin GraalVM build tools. And in order to execute this phase, we have to use pre-native Spring Boot build image. Perfect. But think of it first. Why do I care? Why should I use GraalVM? If you are using microservice today, you already know that you have lots of applications running together at the same time. And it is not only one application of every microservice, it's different instance of the same application, or let's say multiple instances of the same application. And this is itself consuming resources. Usual scenario is DevOps team, platform team come to you and ask you for sizing. The sizing is a matter in cloud native applications and in microservice world. How big your system will be? Let's say 100 of instances. How much they will cost you? What will be the utilization of all of them? And so on. And the GraalVM will support you in this. So it consumes little resources from your memory, from CPU. In comparison with normal application, it's tiny. It's extremely small. At the same time, it provides you with good performance because it's running natively. Even you don't need GVM to start it. However, you might think in order to build it, I am build it for a specific platform. If I build it on Linux, it will work on Linux. If I build it on Mac, it will work on Mac. on Windows, it will work on Windows. How can I overcome this issue itself? And here is Docker come into play. So if you have your native image as a Docker, then done. You don't need anything. Just start up your Docker instance, started on any platform. Platform, of course, have Docker. So let's try this. Let's go to Spring Initializer, and I think we only need this plugin, and this is already the parent. So in order to test, I'll only use Spring Web, and that's it. I have here my terminal, and let's unzip this demo, and let's start it on IntelliJ. All right, so let's first go to Maven POM file, and we will use this plugin. No, I think we don't need anything else other than this, so let's try it first. Let's reload Maven. Also, let's add one single API, simple API to test. And we will add only one API. Say hello. And this perfect API will only return hello. That's it. We're done. Nothing else we need. So thanks IntelliJ. And let's go to, we are already in the directory. So let's use the Maven wrapper. Maven wrapper, pnative Spring Boot build images. Hopefully this will not take much time, but anyway, I'll get back to you from time to time while this build is happening. All right, so first build actually failed. The failure is unable to invoke layer caveator. And actually, from my search on this, I found the issue is, as I already mentioned at the beginning of this episode, I am using a Mac M1 Silicon chip. So let's try to use the shown image builder and see how it will behave. This is the repository from the shown ARM64, and he mentioned here that I need to replace the build with this plugin. And this plugin is using image builder time. So let's try this. Again, let's open IntelliJ. I replaced this with the shown image builder, and let's execute it again. Seeing it is pulling now the image from Docker Hub, starting the image. Let's have a look on the resource consumption of this image itself. This is the image. It seems it is consuming from the memory in order just to build. It's still increasing. Let's try to only stat this. Oh, 3.5 gigabyte of memory and still consuming. And I'm not sure if this will be an issue for you or not, but the builder itself is taking some time. Of course, you are using on production some pipelines to build this, so I believe it shouldn't be an issue. We separate the pipelines of our CI from the production servers, but still consuming memory. So you have to consider this. All right, so done in 3 minutes, which is good actually in comparison with the native builder from Spring. I tried before and it worked with me. So on Mac M1 chip, it's working randomly. You cannot expect what will happen. But 3 minutes to build is something good actually. Now let's see what we have. Okay, so from Docker, we got, this is the image, the builder image, and this is our application. Okay, and the application we got is actually around 100 megabyte, the size of the application, the size on the disk, not the memory, which is fantastic. Now let's see how long it will take to start up the application, and we expect this will happen instantly. So let's see. Docker run. I think I have it already with the same name, demo 001 snapshots. Yes, let's try this. Perfect. Took almost 0.05 seconds, which is really extremely fast just to start. Let's try also to hit the API and see. Okay, so we can use HTTP get localhost 8080. 1 millisecond to load the dispatcher servlet. And this is expected. The first hit on your application might take a couple of milliseconds, more than usual. So if we hit it again, we should get it much more faster. Yes. And if we look at the time for this also, we will see it took almost perfect. This is the first thing we can look at. Also, let's see what we are consuming here in terms of the running Docker instance itself. And this is our demo application. Yes, let's see the stat of this. The memory usage is 28 megabyte. This is extremely powerful. And the CPU utilization is nothing actually. What if we try to stress test this application? Let's try to do this. So again, Docker stat, this one. And I will use Apache benchmark to do this. So ap localhost 8080, and let's start small and see 100 requests, and let's send 10 concurrent users. So we are sending in total 100 requests, but we are sending it 10 by 10. So let's see how long this take. Okay, it took almost 0.05 seconds, and it completed without any failure. Perfect. Let's try to add more load to this. Let's try 1100. Again, 0.236 seconds to complete 1000 requests. Still, the memory utilization is 66 megabytes. Actually, with the Spring Boot itself consume specific amount of your memory, but here it seems it's nothing. This is really fantastic. Let's add another 10,000, almost 2 seconds. And now it's 141 megabyte and CPU utilization is nothing. To conclude, GraalVM seemed to be really powerful, although I am still playing with it, but I wanted to share this with you specifically. Imagine you have now thousands of microservices in this setup. It will be nothing on your infra. It will also give you perfect, actually, performance. Still, I am working on this, and I will share my update on this specifically on Twitter. Hopefully, you got something from this episode, and I might see you in the future. Bye bye.